Hello! Today we're doing notes on 11.7, events involving and also talking about conditional probability. Consider tossing a fair coin 2 times in succession. The outcome of the first toss, heads or tails, does not affect what happens when you toss the coin a second time. So we're going to find the probability of one event and a second event occurring. Independent events. Events are independent if the occurrence of either of them has no effect on the probability of the other. And probabilities with independent events. If A and B are independent events, then the probability of A and B, also going to show you, this is what it looks like in symbolic notation, A and B, it's the intersection of A and B. That's equal to the probability of A times the probability of B. All right, a US roulette wheel has 38 numbered slots, 1 through 36, 0 and 00. Of the 38 compartments, 18 are black, 18 are red, and 2 are green. A play has the dealer, called the croupier, spin the wheel and a small ball in opposite directions. As the ball slows to a stop, it can land with equal probability on any one of the 38 numbered slots. Find the probability of green occurring on 2 consecutive plays on a roulette wheel. So our probability of 1 green is equal to 2 out of 38, which reduces to 1 out of 19. So probability of green and green is 1 out of 19 times 1 out of 19, which gives us 1 over 361. Next, we have to find the probability of a family having 4 boys in a row. Please do this one. Okay, probability of having a boy is 1/2. So probability of 4 boys is going to be 1/2 times 1/2 times 1/2 times 1/2, or 1/2 to the 4th power. So this is 1/16. Probability of an event happening at least once. This is going to be 1 minus the probability that an event does not happen. Remember, at least once means 1 or more times. Okay, if the probability that South Florida will be hit by a hurricane in any single year is 5 out of 19, find the following probabilities and express as fractions and as decimals rounded to 3 places. Okay, so probability of being hit is 5 out of 19. So the probability of not being hit is 1 minus 5 out of 19, which is 14 out of 19. So that will help us, okay? So what is the probability that South Florida will be hit by a hurricane in 4 consecutive years? So remember, probability of being hit is 5 out of 19. So that's 5 out of 19 to the 4th power, which gives us 625 divided by 130,321. This is about 0.005. I would like you to try B. What's the probability that South Florida will be hit by a hurricane in the next this one should say, what's the probability that South Florida will not, very important word missing, will not be hit by a hurricane in the next 4 years? Please do this one. Okay, so if the probability of not being hit is 14 out of 19, then we're going to raise that to the 4th, which gives us 38,416 divided by 130,000, 321, which this is about 0.295. Okay, C then says, what is the probability that South Florida will be hit by a hurricane at least once in the next 4 years? So at least once, remember we're doing 1 minus the probability that the event does not happen. So we're using the probability that the event does not happen. So we're using this one, B, and we're basically going to do 1 minus what happens in B. Okay, so this is 1 minus our 38,416 all over 130,321. So as a fraction, this is 91,905 divided by 130,321, or this is about 0.705. Okay, there are 20 mouth-watering pieces of chocolate in a box. You want 2 and you prefer the chocolate-covered cherries. The problem is that there are only 5 chocolate-covered cherries and it is impossible to tell what is inside each piece. They are shaped exactly alike. The probability of choosing a chocolate-covered cherry is 5 out of 20, or 1/4. Suppose you choose a chocolate-covered cherry on your first pick. Now, there are only 19 pieces left and only 4 chocolate cherries left. So this changes your probability of a chocolate-covered cherry to 4 out of 19. So dependent events are dependent if the occurrence of one of them has an effect on the probability of the other. And probabilities with dependent events. If A and B are dependent events, then the probability of A and B is the probability of A times the probability of B given that A has already occurred. So the probability of choosing 2 chocolate-covered cherries in a row is going to be 1/4 times 4 out of 19. Well, we can reduce those 4s, and this is 1 over 19. You are dealt 2 cards from a 52-card deck. Find the probability of getting 2 kings. Please try this one. So we know the probability of getting 1 king from a brand new 52-card deck is 4 out of 52. Well, once I remove 1 king, that leaves me 3 kings, and I'm left with 51 cards in the deck. So we multiply this together, we get 12 out of 2,652, or this reduces to 1 out of 221. This time you're dealt 3 cards from a 52-card deck. Find the probability of getting 3 hearts. Please try this one. Okay, so there are 4 suits. Hearts is one of them. So there are 13 of the 52 cards are hearts. So this is 13 out of 52. Well, once we take away 1, then we have 12 out of 51. Take away another, 11 out of 50. So this is going to give us 1,716 divided by 132,600, which is going to reduce to 11 over 850. All right, we're going to be talking about computing conditional probabilities next. Conditional probability, the probability of event B, assuming that event A has already occurred. This is denoted by P of B given A. Again, you would say this as the probability of B given A. All right. A letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a letter that precedes H, given that the outcome is a vowel. Do not include the letter Y among the vowels. So let's think. We know that we want a letter that precedes H, meaning comes before H, given that the outcome is a vowel. So let's think. Our vowels are A, E, I, O, and U. And we know that A and E, these come before H. So the probability that our letter comes before or precedes H, given that it's a vowel, is 2 out of 5. You are dealt one card from a 52 card deck. Find the probability of getting a black card given the card you were dealt is a spade. So this time we're given the card you were dealt is a spade. So our spades are all black. And there are 13 spades. And we want the probability of getting a black card. Well, we have 13 black spades, that's our total, and the probability of getting a black card would be 13 out of 13, which is 1 in this case. All right, find the probability of getting a spade given the card you were dealt is a black card. So this time we're given the card you were dealt is a black card, and we want the probability of getting a spade. Please try this one. Okay, in this case, the number of black cards is 26. We have 13 spades and 13 clubs. So given the card we were dealt is a black card, that means our denominator is 26, and the probability of getting a spade, there's 13 of them. So we have 13 out of 26, which is 1/2. Find the probability for a U.S. woman age 40 to 49. So it says express probabilities as decimals, and if necessary, round to 3 decimal places. Okay, so here we have positive and negative mammograms, and then the occurrence of breast cancer or no breast cancer. So the first one says the probability that a person has a positive mammogram given that she has breast cancer. So given that she has breast cancer, again, what we're given always becomes our denominator. So given that she has breast cancer, this tells us 800 is going to be our denominator, and has a positive mammogram, so that's this number here, that's going to give us our 720 out of 800. So that reduces to 9 out of 10, or 0.9. Next, we have to find the probability that they have breast cancer given that she has a positive mammogram. I would like you to please do this one. All right, in this case, we are given that she has a positive mammogram. So this is our total from the total of positive mammograms, 7,664. And we're looking for the probability that she has breast cancer. And so we're again looking at this breast cancer. So that tells us 720. And this reduces to 45 out of 479. And this one, we're going to have to give an approximation. This is about 0.094. This is our official formula for conditional probability. It's the probability B given A is equal to the number of outcomes common to B and A divided by the number of outcomes in A. So again, you're always using the A, what you are given, that's always your denominator when setting these up. And that's what we have for today.